Hello, dear students, scholars, and learners. I am welcoming you all to my new session. Yes, it's true that I will be discussing on a very important and new topic. Though the topic is not new to you, but I must say one thing that the topic is very important one. That's why I choose the topic for today. But before starting the topic, I'd like to say something that yes, I'm meeting you after a very long time. It is just because of my some personal and professional reasons. So let's move on to the topic. The topic that I selected it is solubility, and I think you guys better know what solubility is. And for me, it's a silly, short, and simple topic, but has a depth information, has depth importance in pharmaceutical and non-pharmaceutical science. So let's start the topic. Yes, it's true that you all know that the term solubility has a good relation to the another term. It's an important and very familiar to you. It's too much familiar in comparing with solubility, that is solution. So while you are learning solubility, any students, any scholars, or any person, when he or she is going to start learning solubility, he or she must have to learn solution first, because solubility is a matter, is a thing, is a topic, is an word which has good relation to the term solution. So we all know what solution is, or what does the term solution mean. So for a clarification, for better understanding the topic solubility, I'd like to define the term solution first. So the common definition for solution is that it is a homogeneous mixture. So in the total solution definition, the word which is very important, it is homogeneous. That means it's a homogeneous mixture of one substances into another substance. So I didn't just tell the name of the substance. You already knew that the which one substance is another substance, the name of this that substances. So what I said, that solution is a homogeneous mixture of a solute in a solvent. That is, one substance is solute and another substance is solvent. And it is almost clear to all of you, I know that. But thing is that it's not mandatory that your solution contains only one solute. Yes, your solution may contain more than one solute. So you can define in such a way so that one definition can cover all the examples. Like, a solution is a homogeneous mixture of one or more solute in a particular solvent at a particular chemical condition. So these conditions may include pressure, this condition may include atmospheric um, things like temperature. So temperature can change the level of solubility. Temperature can affect your solute tendency to go to the solvent, to mix thoroughly, to dissolve itself within the solvent. So let's see what the definition is for solution. Definition is solution is very simple. It is a homogeneous mixture of one solute or more than one solute into a solvent or into particular mixture of the solvent. That is the another part, and I would like to cover the part later on in some other video, and it is called co-solvency for making your solute completely solubilized within the solvent. So let's see why it's important to learn solution. Solution is important because you need to have the good sound knowledge on solute and solvent. In pharmaceutical science, the term solute is equivalent to another common word, that is active pharmaceutical ingredients, or any pharmaceutical substances like excipients. Active pharmaceutical ingredients are referred as solute in chemistry. But in pharmaceutical science, all solutes are either active pharmaceutical ingredients or excipients, or you can say directly these are drugs. these are drugs. But though it's true that don't compare that active pharmaceutical substances are accepted, are declared as drug, but not the excipients. But for ease of study, for ease of understanding, you can say that active pharmaceutical ingredients, that is simply or shortly, it's APIs. These API and excipients can be declared as the solute molecules while you are dealing with the solution, dealing with the term solubility. So let's see, what is solubility, or what does the term solubility mean? So solubility is actually, in short, in general, it is the ability of the solute molecule. That is, in pharmaceutical science, it is the ability of the drug substance. It is the ability of the chemical moieties. So in short, you can say solubility is the ability of the solute molecule to be dissolved completely in the particular solvent at a defined or specified condition. This is the definition of solubility. This is the definition of solubility as a statement. But in quantitative way, you can define that solubility is the concentration. Concentration of what? Concentration of the solute molecules, concentration of the drug substances that is present in a saturated condition. That is, concentration of the drug substances, concentration of your solute molecules which present in a solvent as saturated condition at a particular temperature situation. So this is all about the definition of the solubility. But in pharmaceutical science, solubility may be expressed in different ways. Solubility product is the another thing. Okay, in pharmaceutical science, you have to deal with the raw materials. You have to deal with different chemical substances that are completely new to you. So judging the solubility profile, judging its capacity, how do they interact with the solvent, is very important. So how do you do that? It's very simple, that you have your sample, you have your raw materials, sample as raw material, that means as API or as excipient or new chemical substance which is completely unknown to you. Especially it is a part of research and development. And I must say one thing, that in pharmaceutical industry, analysis covers a vast area than comparing with the research. That means more people are doing analysis, not the research. So research and development, the person working in the research and development area, they are doing research, and the chances of doing something new, it is available, it is applicable in R&D department. But while you are working in quality control, while you are working in a common laboratory, in that case, or it could be conducting of research work or analytical work in university lab. In that case, you have to check the solubility of your materials, because for the drug absorption, your solubility profile is very important. And yes, it's true that in case of product and development, in case of research and development, pre-formulation study is very important. And in case pre-formulation study for a particular pharmaceutical moiety, for a particular pharmaceutical drug substance, solubility profile analysis is a must. So what I said, that solubility have to be judged, solubility need to be assessed before taking decision on a particular moiety. So what I said, that in case quality control analysis for raw materials, especially for raw materials, I must say, especially for raw materials, solubility is very important to check, because solubility actually help you to ensure that partially, yes, it's partially, that is the way of partial identification of your materials. You can identify your materials, for example, according to your method, according to your method could be in-house, or method could be from the compendial books. So according to your method, if it is need to be dissolved in the in methanol, it is need to be dissolved in any other organic solvent, it need to be dissolved in case of any inorganic solvent like in water. So if it is dissolved at a particular quantity, what is exactly mentioned in the method, and if you have the good result from your material, that means your material is okay for conducting further test. You may proceed with the material for further testing. So this is the most important parameter. I repeat, it is one of the most important parameter in pharmaceutical industry while you are judging, while you are assessing, while you are testing your raw materials. So what I said, the solubility is the ability of the drug substance to be completely dissolved in the particular solvent. So for example, uh, you have 1 gram of any chemical substance, 1 gram sodium chloride, for example, 1 gram sodium chloride. So how much maximum volume of solvent required to dissolve this 1 gram of sodium chloride? It is the solubility, that is in quantitative way. So for that, so by comparing these all these things what I mentioned, that any material, so material solubility can be different. One material can respond to a particular solvent in one way, another material can respond your same solvent in different way. So this could be happen. So according to this concept, different pharmacopoeia mentioned the solubility profile in pharmacopoeial journal chapters. Like, and most importantly, I would like to mention USP, and we would love to follow the monograph from USP. So what they said that they are different descriptive items, like your materials could be very soluble in particular solvent, your material could be fairly soluble, sparingly soluble, slightly soluble, very slightly soluble, or practically insoluble. So it is expressed and explained in pharmacopoeia in this way, that I'd like to share this matter to you, that for your descriptive, you got your descriptive items like a very soluble. So in that case, what is the part of solvent required to uh, dissolve per part of your solute? If it is less than one, that is less than one part of solvent required to dissolve your selected amount of the solute, or unit amount of the solute, in that case it is very soluble. It will be expressed as very soluble material, that is your material is very soluble. If it is, the ratio is in between sorry, 1 to 10, it should be expressed as freely soluble. It is between 10 to 30, it will be expressed or referred as soluble. 30 to 100, it will be referred as sparingly soluble. 100 to 1000, it will be referred as slightly soluble, and 1000 to 10,000, it will be expressed as very slightly soluble, and 10,000 or over, that means your material is referred as practically insoluble. Yes, you can make it solubilize through which way? Through what I mentioned at the very earlier of my today's session, that co-solvency. That is the co-solvency. You can use any other solvent with your present solvent, or you can replace the solvent with one or more solvent to make a co-solvent for particular co-solvent for your practically insoluble material. So solution, learning about solution is very important before learning solubility, and solubility as well as solubility product are very important while you are performing pre-formulation studies, while you are analyzing your raw materials. Solubility profile will tell you many things about your materials. Your material is soluble according to your method, that means you need not to think more about your materials. Your materials might be fit for your further fit for the conducting the further test, like pH testing, refractive index testing, melting point testing. These are also a partial way of identifying your materials. But I must say one thing: the solubility is very important to check, especially for raw material testing, and important to judge while you are conducting pre-formulation studies in R&D laboratory. So this is all about solution and solubility. I think you got the point. And especially when you are working in the quality control laboratory, you will have to face the term as a test parameter for raw materials I mentioned. And I love to deal with this matter very much because one more thing I would like to mention, that in case of judging, in case of dealing solution or solubility, that means solute has loving tendency. Obviously solute should have loving tendency to the solvent so that it could be completely dissolved in the solvent and make a homogeneous mixture. So that's it for today. I think you have enjoyed the total session. So you can say your suggestion, your advice regarding today's matters. And if you have any topic of importance, topic of choice in your mind, you can share with me in comment box. Thank you very much for watching the video. And I must say one thing, that learning is actually earning huge thing, and it will make you fit for your future application, for your future journey. Thank you very much. Good night.